Good evening, and welcome to SkepTalk, the monthly speaker series hosted by the Bay Area Skeptics. Before tonight's presentation, a few words about Bay Area Skeptics. As North America's oldest skeptical organization, we are dedicated to promoting critical thinking, logic, and rational thought. In the 1970s and 80s, scientists such as Carl Sagan and magicians such as James Randi established the scientific skepticism movement out of concern about the popular fondness for pseudoscience and the lack of public science literacy. Scientific skepticism embraces evidence-based civil discourse on health, education, consumer protection, and especially the investigation of extraordinary claims. Using the scientific method, we hope to promote skeptical inquiry to reduce irrational thinking in society. This talk is supported by Bay Area Skeptics members such as you. Please visit us at baskeptics.org or join us on Facebook, Twitter, and Meetup. Consider supporting us through convenient monthly donations via Patreon. Patrons receive premiums such as discounts and free t-shirts for our annual Skeptical Conference. But more importantly, members help us make the world just a little more reasonable and rational. And now, tonight's speaker.
I was going to say good evening, but I understand we have at least one viewer from New Zealand, so that doesn't quite fit. So I'm going to just say hello. Thank you for joining me for Mike Simmons' SkepTalk. Superstitions, Aliens, and Conspiracies. Tales from the Frontlines of Astronomy Outreach. I'm Dave Allman-Smith, and it's my pleasure and honor to introduce our speaker, Mike Simmons. I usually gloss over the curriculum vitae of our speakers, but I'm making an exception this time because it's so interesting. Mike founded Astronomy Without Borders. He is a scientist at the Blue Marble Space Institute. He is a founding member of the Overview Institute. He is on the board of directors of the International Dark Sky Association. He serves on a committee of the African Astronomical Society. He is a committee member of the International Astronomical Union Working Group on Equity and Inclusion. A minor planet was named Simmons after him. And the Société Astronomique de France awarded him a prestigious prize for, quote, setting a worldwide example that astronomy transcends political and cultural borders. Okay, you'll agree that's impressive, and I encourage you to go to the Bay Area Skeptics website because there you will find links to these various organizations, and I tell you, they're really interesting and fun. Let's see. Also, let me encourage you to post questions during and after Mike's SkepTalk. Okay, Mike, take it away.
Well, thanks, Dave. I always feel embarrassed about these little honors and things. You know, I got a rock named after me. It's somewhere out there where nobody will ever go, but that's the way it goes. So anyway, I do get around though, and I'm going to talk tonight, I think, a fair amount about some of the things I do in other countries as well, because there are cultural differences and so on. Now, the thing about doing astronomy outreach is that I know a lot of you people, all you people meet the usual science deniers and things like that, but it really is a little different in astronomy. So I'm going to point out some of that and why that's the case. So let me bring up there we go. Okay. So what I want to do, I'm going to start off with something that shows the international nature of astronomy. Astronomy is one of those things that everyone knows about, everyone hears about, everybody is fascinated by. It's in every culture. It has been throughout time. And this was a program I ran for the International Year of Astronomy in 2009 called 100 Hours of Astronomy. And one of the main things that we did was what's called a star party. You take your telescopes out and look, a public star party, you invite people to it. So we did a single star party, 24 hours around the world. These are just the places where we had events scheduled, including the star party, and that was the main thing. But I want to give you a feel for how astronomy, two things about astronomy. One, it's everybody, everywhere. The public is always fascinated, makes it pretty unusual as far as the sciences. But the other thing is that there are legions of people around the world, like this person here. This is in Long Beach in the US. He is what's called a sidewalk astronomer. He's got his telescope out there showing somebody the sun. And there are people in every country who do this. So this makes astronomy different than all those other sciences that all of you do, because people are interested in biology in different ways, but you don't have amateur biologists going out on the sidewalk and saying, hey, you got to see this plant or this animal. It's just, there's certainly outreach and education, but these people are everywhere. And I'm going to show you some examples of that. So from the USA, we go to Kurdistan in northern Iraq. I actually took that telescope to the astronomy club there because they could not get one on their own. This is all in the same night as it shifts around the world. Farther south in Iraq, in Baghdad, and this was during a time when crowds were targets of terrorists, because it's 2009, a bad time during the war there. Excuse me, but they were going to bring people out anyway. They had a crowd of 500 people there, and they were going to take part in this big worldwide event. This is in Bangladesh. This is in another country which I always forget, looks like Asia. I just love the clothing with the stars on it there. A girls' school. This is looking through a telescope in Kathmandu, Nepal, in India, in Iran. Same telescope here, pointed in the opposite direction, but this one is in either Bolivia or Peru, I forget which. Again, the same event. This is Argentina, a very big event. And then later on in the organization that I founded, here are some people taking part in the after follow-up events in following years from Oman. Again, I forget which. This is North Africa. Don't remember which country. Pakistan. Young people, like it is in most of the world, in the Philippines there. And this is why they do it, because here we're looking through a special type of telescope, H-alpha telescope, looking at the sun. This could be anywhere, but this is what happens when people share these views. They are doing it because this is the payoff here, this young boy. And this could be anywhere in the world, happens to be in Romania. But everybody wants to share what they're seeing here. So this one's in Brazil. So it really is everywhere, and it has this legion of people who are doing outreach all the time. And so we all deal with some of the things I'm going to show you here. So let's start off with a few things. Now, this is the exact wording of a voice message I received on the organization's voicemail that planet Nibiru is in the sky right now, and this guy is very excited about it. I didn't go out and look for it because I knew the moon was up right then. But this is one of the things about astronomy, it makes it different, is that people don't know you can see the moon during the daytime. And when they see it, they're shocked and they say, why can you see it during the day sometimes? Well, it's sometimes because one, it's up, and two, you looked. Most of the time you're not looking. This is a thing that happens a lot. People say, well, I saw something in the sky. And I said, yeah, I see it all the time. But, you know, it's just some of us are nutty enough to be out there looking all the time. So it's a lack of knowledge. And, you know, people don't know, for example, what creates the phases of the moon. They don't know if it's, and this is easily been documented many times, they don't know if the moon's phase is going to be the same everywhere in the world at the same time. Well, it is, because it has to do with the geometry between the Earth, moon, and sun. Looks the same from everywhere. They get very confused about what eclipses are, which, okay, so we have a little blame for that, because lunar eclipses are eclipses. Solar eclipses, it's really not an eclipse. It's a different kind of a thing. We use that. So, okay, we goofed on that one, but we can't change it now. But look, if you're a biologist, you don't have to explain to people what an animal is, or what a plant is, or how they're different. But if you're an astronomer, people do not know the difference between a star and a planet. In fact, they don't even know what they mean. They don't know what stars are. People will wonder if the sun is a planet or the moon is a star. They're things up there, and they don't really know. And then we have to deal things like with this Pluto, a planet or not. I'll just mention that we've been through this before when minor planets, asteroids, were first discovered, and they were called planets, and then they found out there were so many of them and they're not the same, so they changed it. Pluto didn't get demoted, it was just called the wrong thing in the first place. It happens. The main thing is astronomers don't really care. I mean, it's a thing. It's a continuum. And then there are things about cultural perspective. So I know one person who was in India, Dharamsala, where the Tibetan monks are, who cannot be in Tibet and practice what they're doing. And she was teaching them astronomy. And she said, these are very smart people. They're very well educated about many things. But when she mentioned people landing on the moon, they said, wait, what do you mean? The moon is a place where you can go? And it just wasn't part of their culture, that this is a thing you can go to and stand on. They understood it. They didn't have any problem with it. It just never come up before. So now, some of the things that we have to deal with as astronomers. There's that. And we deal with this all the time. But of course, if you are a cosmologist, you have to answer this question. It's cosmology, not cosmetology. So people don't really quite understand exactly what we do. And that shows up in a lot of ways too. They think that astronomers, professional astronomers, and amateur astronomers may be called stargazers, and that's fine because they're looking all the time. Professional astronomers don't do that. They don't even go to the observatory most of the time. And this is the way that the observatories are represented. That big telescope sticking out of the dome, which means you can't close the dome, which is the whole purpose of the dome. It doesn't work this way. But most people have never seen anything like an observatory dome. And then we have this. This is, of course, the tough gang of astrophysicists who monopolize the telescope. Don't let anybody else look. But in fact, no, aside from the fact that, well, okay, maybe there are tough gangs of astrophysicists, but this is not what they do. You don't go to an observatory and look through it. So people really don't even get what astronomers do. They work with telescopes remotely, or they don't collect the data at all. Most never go to a telescope or use one. So in reality, if you do go to a professional observatory, unlike the pictures I showed you here, this is the reality. This is what it looks like. This is a control room of a modern telescope. And even the older telescopes have control rooms like this now, because you got a camera on there or some other instrument. And so you're collecting data. This is not just joyriding with the telescope. So, but people don't know that. And I don't blame people for, I've got to say, for not knowing these different things. This is not a case of not caring. That it just, this doesn't come up in ordinary life, and people don't interact with the things in the sky, and it just isn't something they would know. Well, we all need to deal with these people who are convinced that the Earth is flat, because you can go out and look and it's obvious it's flat, right? And the fact that I've gone around the world on one of my trips where I had to go to a conference in France and then go to one in India, or someplace in Asia, in China, and then back around to the Pacific coast of the US, you know, that would be lost on people. And I won't dwell on this too much, because most of you guys need to deal with the flat earthers and people like that who really kind of ignore the evidence. But this is just really a lack of taking a look at things. The Greeks knew the Earth is round. The ships going over the horizon, they disappear. The Earth's shadow on the moon is always curved. The only thing that can create the same shape of shadow like that, a circle, all the time, is a sphere. Eratosthenes in Greece more than 2,000 years ago measured the diameter of the Earth by looking at the shadow of the sun in two places a few hundred miles apart. And you know, so, and his measurement was pretty accurate. So, but then also, you know, I even had a student that I was helping in Kurdistan in Iraq, northern Iraq, asking if I had any photos that I could give him that would convince the other people there who thought the Earth was flat. And I said, well, you can take photos too. And they said, well, they'd trust it more if it came from you. So that's kind of an appeal to an authority, because I'm a scientist in the US. Cultural differences, really. So the thing is that even these people, I've talked to people who are really science deniers in a huge way. And then when I say this is like believing in a flat Earth, you know, other people believe it, they're amazed that anybody believes in that. And the stuff that they believe in is just total nonsense too. There's no difference. I don't know how that happens. But you know what? It could be worse, and probably will be soon. And this is the latest model of the Earth that somebody came up with. And I haven't really encountered anybody that thinks we live on something like that. But, you know, imaginations go wild. Okay, so this is what most people know about space. And it's hard enough for geeks like us to enjoy things like Star Wars with all the funny things that go on that can't go on. But, you know, I'm actually a Star Trek fan, and I just deal with it. You know, it's Hollywood. That's fine. But making the Kessel run in less than 12 parsecs. Parsecs are a measure of distance. And so somebody didn't do their homework there. And I will say that there is an entire addition to the canon of Star Wars that explains this and uses relativity and all kinds of things, and just presents more problems than it solves. It's wrong. But most people would never know. And, you know, I believe you've had Phil Plait, the bad astronomer. He's the one that deals with all this stuff. Everything that's wrong in the movies and everything else. And it's a great way to educate people too, who are willing to listen. So, you know, what I do with sci-fi is I just watch the movie and take the premise. It's a movie. But sometimes it miseducates people. And as far as the media in general, we have all these things that happen all the time. Even reputable media will publish things that are total and complete nonsense in astronomy. So since 2003, when somebody published something about the Mars was closer than it had been in 70,000 years, which nobody except an astronomer would even be able to tell it was any different, maybe a little bit brighter in the night sky. It was a huge, gigantic thing, and people didn't know it's just about the same 2 years later. And somebody published something about Mars will be as big as the full moon. So we had to deal with that one and explain to people why that's not possible. If it did happen, we're in big trouble. But that thing comes up every year. So every August since 2003, we hear that Mars is going to be as big as the full moon in August. So that's one of the things we deal with. Some of you who are aficionados of Ed Wood and Plan 9 from Outer Space will recognize this guy. His name is Criswell. He was in that movie, but when I was young, back in the Middle Ages, he was on TV in Los Angeles. He had a regular program and he would predict the future. And one of the things, just before he went off the air, probably planned this way, he predicted the end of the world and he named the date. And I was 7 or something like that. And I was thinking, well, this is the day, and I don't see any of the adults acting like there's anything wrong here. What is going on? And then the day passed, and I realized, okay, the world wasn't really going to end. I should have kept track of how many times I've seen the world end based on something astronomical. We get asteroids that are coming close to the Earth. We say it's close if it's 1 million miles away. It's not hazardous. Unfortunately, these are sometimes referred to as potentially hazardous asteroids because sometime in the future, they may get into an orbit that could make it possible for it to hit the Earth. It doesn't mean it's hazardous now. In the 1970s, I was working at Griffith Observatory in Los Angeles, and we had an alignment of the planets, and it was going to rip the world apart. That was probably about the 10th time I'd seen the world coming to an end. But in that case, I was working at the premier facility doing outreach in Los Angeles, so I had to deal with that. I did a calculation of the gravitational pull of all the planets lined up together, and it was like less than the gravitational pull of the person standing next to you. So, of course, it happens all the time. 2012, remember the Aztec calendar fiasco, those naughty Aztecs? Because their calendar didn't go past 2012, somebody came up with the idea that says they know the world's going to end. That program that I showed, 100 Hours of Astronomy, we had a live webcast for 24 hours from observatories around the world. It was a big deal in 2009 to do something like that. And I got this call from IAU headquarters, frantic call that during the webcast, this was, can't remember the name of the company. I don't know if they're still doing this, but it was supported by ads. And one of the ads that came up was about the Aztec calendar and the destruction of the Earth by some rogue comet. So it was impossible to get away from. This goes way back to Halley's Comet in 1908. People were selling comet pills and there were suicides because the Earth was going probably through the tail of the comet and nobody knew what it was made of, so people were saying, well, it's going to be poisonous and so on. And nothing happened, of course. So we deal with this a lot. Now, here's something that is not limited to astronomy, but we probably are the ones people come to. Yeah. I title this one the UFO base under the Pacific Ocean because it's a recent encounter on Nextdoor. Nextdoor, that place where everybody goes to share accurate, precise, and well-sourced information. So somebody posted a photo from their Ring camera. Early in the morning, it showed something very bright, but it was like cut up in different ways. It looked kind of odd. And so everybody around the neighborhoods chimed in about why it was a UFO. which means unidentified flying objects. So of course we have to point out that if you don't know what it is, it's a UFO, but of course they mean alien spacecraft. And this happens with things constantly. People see a very bright meteor, they think it's a spacecraft. Bright planets. In this case, what they'd captured was a full moon setting towards the Pacific Ocean. And somebody else actually is the one who before me figured out that the moon was over there, and I checked it out and said, yeah, it was exactly where the camera was pointed. And somebody replies with, it's not the moon. So I said, okay, fine, the camera's pointed in that direction. It captured this alien spacecraft. Where's the moon in the picture? It's got to be there. Didn't get a response to that. One of the other people said that they knew it was a alien spacecraft because she could see the UFOs falling from outer space into the Pacific Ocean, where they have a base under the water. And she said that they would fall for a long time and they kind of slow down and then they would disappear in the water. And I pointed out that we have planes taking off from Los Angeles International Airport. I see them taking off, heading to Asia, major hub for Asia. And when they go over the horizon, they appear to touch the horizon. Now, if you know that the Earth is a sphere, then you realize this is what you would expect. So they weren't falling in a straight line straight down. So there was some limited ability to figure that one out. Let's see, what do we get? We get the face on Mars. There's a new one that just came out. Apparently there's a picture that shows a door on Mars that goes inside the surface of Mars to the inner workings. Who knows what goes on in there? I don't know. People who have talked to aliens, or they come up and they say, can you tell me about SAO, some number? And I said, and if I play along, they will admit that they're in touch with people from this star. So this is so common, and it goes on so much. I could talk about this all night, and sometimes I kind of have to. My reaction to all this stuff is simple.
This is some bullshit.
Yeah, but I can't say that to everybody. Well, let's move on to the next thing. I'm using Fantasia and Mickey's Sorcerer's book here because I don't want to offend anybody, because this is not about religion per se. It's about what people believe and their willingness to accept observation. So religious dogma can be a real problem. Now, we can deal with that here. It's not too difficult, but I know, and they're astronomers. Astronomers are religious people too. I mean, the Vatican has an observatory that's very good research observatory. One of my college professors told us how to remember a constant because it included 666, which is the mark of the beast. And that's all fine. The problem is when it comes to real extreme cases. Now, I work with people in Afghanistan, and even before the Taliban took over Afghanistan, again, a friend of mine had to leave the country. He was teaching girls as well as boys, and he was teaching astronomy as we know it. And I knew we had talked, and he told me that he has to deal with the fundamentalists who say the Quran says this. And their interpretation. The books do not say this is this and this, it's interpretation because they're interpreted differently. He had to leave the country because his life was in danger. That's before the Taliban took over. So there is much more going on there as well. And most people are willing to look at it and say, well, fine, this is the evidence. God created that. This is how God did it. I mean, if he made Earth, he made us, he made everything else. These things that we find just give us clues as to how it was done. But not everybody's willing to drop the ideas, the interpretation, lack of information they got from 2,000 years ago. I will say one thing about my travels around the world, that I get far more religious dogma that is contrary to observations in the United States than I do in almost any place else. Now, Afghanistan, it's another issue, but I go to Iran quite a bit, and they're huge on astronomy there. So I take that for what it is, but there are cultural differences. So, okay, well, everybody gets this one. Einstein was wrong, and I can prove it was wrong. And of course, this is the famous cartoon about with the second step there, then a miracle occurs. This is a very common thing, and it always comes from people who have no education in physics. So they can't really describe what they're talking about, but they've come up with something new, and they want our help to get published in a major journal because nobody will publish them. And I agree with the publishers. The other thing is we get a lot of questions about limitations of physics. For example, traveling faster than light. If I say we can't go faster than light, so it'll take this long to go there, the answer is as far as we know, because science is changing. We keep learning new things. So if you want to take the things that seem to be absolute constants of the universe and say, we don't know that they're right, then you really don't know anything. I mean, there's nowhere to go with that. So that's kind of a difficult one, but you know, if people want to believe what they want to believe, you can't do anything about it. It's just that people don't differentiate between different things based on the strength of the evidence and the probabilities. This is, of course, what all of you skeptics have to deal with, but it seems to be much more likely in astronomy because we're dealing with things that really are on the frontier and things that are really incredible. The picture of Sagittarius A star black hole at the center of the galaxy, it was just released today. Yet that's kind of like not a normal thing, you know, and then we get questions about it, and then people say, well, that can't be, or you know, so we hear about discoveries all the time. And the wonderful part of it is that people who know what I do will come up and say, I heard about this thing. It's absolutely incredible. What I don't understand is this. And I get to tell them about it. So most of the time it's great. But then for those few that you tell about it and they say, no, that's wrong, that's where it becomes a little bit difficult. And of course, well, you may all know the BS asymmetry principle, where somebody says the moon's made of cheese, and you explain all the reasons why it's not the case, and he says, yeah, I'm still thinking cheese. Fortunately, most of the time, if people seek out astronomers to ask questions, they are really interested in the answers, and because they really don't know. And the most common, and to me, the most wonderful question that people can ask is, how do you know that? How do you know how much iron is in the atmosphere of this star that's so far away it can never appear as anything but a point of light? And this is scientific inquiry. I mean, they're asking about it, and so I love getting those questions because they simply want to know, and that's wonderful. So I won't go too much into the moon hoax stuff because this is too common for everybody. Just say, you know, a few things about it. It's actually people have figured out what it would take to fake it, and it would be a lot harder and more expensive than just going there. And there are some things, like I understand the Vedas say the moon is farther away from the sun. Seeing eclipses doesn't seem to change that. Oh, it was Dave actually earlier told me that in Africa, and I am involved in Africa, I hadn't heard this one. Somebody told him these guys shouldn't land on the moon because you can't stand there. It's just made of clouds. And then the whole thing about why no stars in the photos, the shadows are somehow wrong. We've all heard this stuff. I heard a recording once years ago in the 70s at Griffith Observatory, a caller who called in and said that it couldn't be real because they showed the Earth from the moon and it was in one phase, and then if you look up at the moon, you could see it was in a different phase. And he just simply didn't know that they're going to be in opposite phases from the different perspectives. Now, the one thing that's interesting, it's a little shocking, when I go to some other countries, less developed countries, not as good education, and people know I'm a visiting astronomer and I'm known and this and that, and they ask me if I've been to the moon. I don't know how many times I've been asked if I've been to the moon. It's like, wow, there haven't been very many people that go to the moon. Definitely not me. Yeah, sorry to even bring this up, but I want to say that they, who are controlling everything, this is much more common in many other countries, far more than the US. It even compared to the way things have gone in the US in recent years. And I don't find that surprising that they have all these conspiracy theories, because their governments in many places are lying to them all the time anywhere. They're corrupt. They don't trust them. And sometimes they'll accept what I tell them, but they don't trust their government. So they're coming up with ideas the best they can. So I get that quite a bit, conspiracy theories in other places. Okay, now here's an example of an astronomical phenomenon. It generates all kinds of things in certain parts of the world. Yeah, this is a picture I took over the Great Wall of China at the western end in the Gobi Desert, northwest China. So South Asia in particular has got a lot of superstitions, including astrology. I mean, in India, probably 95% of the people use astrology to plan their day. They believe it is real. And I even know astronomers who are working at astrology institutions, because there are a lot of those. They do astronomy too. I mean, that's their home thing. And there really aren't any choices, but they're able to do their astronomy. So some of the things that they have for eclipses in particular, you shouldn't eat certain foods during an eclipse. So my outreach friends, they go out and offer people during eclipses, offer people all these foods that they're not supposed to eat because it'll be dangerous. They eat it, they give it to the other people. Pregnant women should not go outside because the eclipse's rays are harmful to the fetus, so they have to stay inside. Now, of course, the only thing that's happening here is some of the sun's light is being blocked. It's not changing. It's not different. It's just less. But this is the way these things come up. And the thing is that these cultural misconceptions of nature, just as religion, which is, part of culture as well, and other things, they really persist. It is a real difficult issue because it's a part of the native culture, and it's hard for them to let go of these things. And as I said earlier, even in the West, people mix up astronomy and astrology all the time, though the difference really is most of the time they'll just say that I'm somebody who does astrology, and they know that it's astronomy. They just get the words mixed up. Now, here's the other thing too, and we dealt with this in 2017, and we will in 2024. And for people that are eclipse chasers like me, we deal with it all the time in different countries. What is the big deal about a few minutes of darkness anyway? And this is a map of the path of the total solar eclipse in 2017 that went all the way across the United States, coast to coast. And you have to be in that path to experience it. We try to educate people. They say, well, I'm going to get 90% of a total eclipse. Well, here's the thing. It's either total or it's not. There isn't any 90% of it. Almost seeing a total eclipse is like almost winning the lottery. You don't get anything for that. And we have to explain this to people because it is the most incredible natural phenomenon you will ever experience. Such that, when people say, well, I think I saw a total eclipse when I was young. No, this is sort of like saying, I think I got hit by a truck once. If you did, it. Total eclipse is that level. So we have to deal with this all the time too. 2017, we have big problems with the schools who will not let the kids go out and see the total eclipse. Now, first of all, during totality, you can look at the sun because the bright part of the sun is completely covered. The corona and everything may be as bright as a full moon. Absolutely harmless. But they're so worried about liability. And this is because they don't really understand. And they get mixed messages. Even some people who should know better, like optometrists or ophthalmologists who consult with the governments, will get it wrong. And then there will be all these warnings about you cannot look, there is no safe way to do it. And so we're going to go through this again in this country and Canada and Mexico in 2024. I will just tell all of you, you got to be there. You got to be in the path. You won't regret it. It's something I can't really even explain, but you won't regret it. Now, one of the things we do when we travel to other places for the eclipse, and we meet local people who happen to be there, where we have chosen to go observe. And we share with them the views of the partial eclipse, usually with these eclipse glasses. This is one in 2006 in Africa. I was in Turkey here leading a tour, a mother and daughter who we shared these with some students in Egypt. This is all the same eclipse path. This was an avid eclipse observer we shared glasses with in China, where I took that picture from the Great Wall of China. And even in Antarctica, where a friend of mine went, the locals were curious, and he regretted not having brought more of the solar eclipse glasses, but that's the way it goes. Now, before we talk about too many goofy things, I want to say a little bit about astronomy. Now, my thing now is starting a new organization that will make an effort to use astronomy for good. How can we use astronomy for good? I get things all the time. For example, with this program that was part of what we did in the organization I ran, Telescopes to Tanzania, Education as a Path to a Bright Future, is what they would say. This is a reasonably well-to-do classroom for a rural classroom. But you see, they don't have any materials except for that one thing that I'm pretty sure a friend of mine took to them when he took the picture. And people would say, when we're crowdfunding for telescopes to take there, one comment I got, I think, is just sort of epitomizes that. I think they need food more than they need telescopes. Well, you know what they need? They need educated people who can help to grow that food, develop the infrastructure necessary for that, distribution, irrigation, all the things that are needed so they don't have to get food from us. They can do it themselves. And people I know in countries all around the world, especially in the developing world, are using astronomy as a way to introduce the sciences, all the STEM fields, to students and into the schools. It's a universal interest, and unlike having a bio lab or a physics lab and so on, the places that don't have these facilities, they have the astronomy lab. And in a classroom like this, you can go outside at night, and they've got a better lab than I do because I'm too close to a city that's ruined the night skies. And so these things, astronomy works really well to introduce all of the STEM fields that involve science, technology, engineering, and math. And this is a person who ran that program, got it started, and is still going on. Now, when they had an eclipse, we sent some eclipse glasses with them. A busload of students came from another village because they said, we want to be scientists too. And when they looked at the sun for the first time, and think about it, you know, the sun's up there, you don't look at it. I mean, people do not see the sun really, and you shouldn't look at it. But with the glasses, you can take a look at it and see what the sun is like. And this is what they want to do. They're doing science now. And I love this picture from Uganda, taken before that eclipse as well. Back in Tanzania there, I was in contact with a young American in the Peace Corps, and he was teaching science to students in Tanzania. And he asked them to make a sign about why they wanted to study science. And they had all their different reasons for it. So getting into science in places like this can be very, very difficult. And but astronomy is a gateway science. You can go from that. There's astrobiology and chemistry, geology, engineering of telescopes and other instruments, all kinds of sciences. So it is a good way to introduce things. In fact, this one is a STEM center and refugee camp in Nigeria. These are families who have fled their homes in Nigeria because of Boko Haram and more terrorists that people have to run away from. So this is in a shipping container, and this is the children inside, and they're doing astronomy, and that remains there. But they also do regular STEM camps for girls, because the girls don't realize that they can be scientists if they want to. And this was started by a remarkable young woman who works at the Nigerian Space Agency. Yes, they have satellites, 5 of them, last I heard, and wants to be a role model for these girls and show them that they can do things. So this is, Dave mentioned that I work with the IAU's Committee on Equity and Accessibility. And this is what I'm focusing on now, using astronomy, which works in any country, in any culture. One of the things I want to do, actually, this is a new crowdfunding effort. This is middle school astronomy clubs in 5 different cities in Libya. Very enthusiastic, bright. They have good teachers. They have support from the Ministry of Education. We can't get telescopes. And there are a whole bunch of reasons why it's difficult. The thing that's holding it up right now is finding a way to ship them over there without paying a fortune, because it costs more for shipping than it does for the telescope itself. So we will be getting the telescopes over to them once we get that going. Now, what about other people? Well, as I said, everybody's interested. We think of astronomy as being a visual science, and it is largely true, but mostly because things are represented that way. The picture of the black hole at the center of our galaxy that came out today, that is not necessarily the way it looks. These are different wavelengths. This is radio telescopes that were used to get this. So we represent things in a way. Most of astronomy, you can't see the object. The Hubble pictures are great. You know, people ask all the time, are those the real colors? And that's a whole thing about how we interpret colors and everything else. But these things can be represented in other ways, and they are. And they love this. There are also people who are legally blind can actually still see high contrast objects like the moon through telescopes or binoculars. So this person may not be able to tell who she's talking to, but she can see features there. There are a lot of ways of giving opportunities. This is another thing that I'm going to do more work, and there are tons of resources that aren't being used enough in outreach and education. This is a planetarium program. We go to a planetarium, we look up and we see the stars there. But there are other ways to represent them. This is by feel, and there's a narration, and they follow the dotted lines to the stars. They feel where the constellations are. There's also a way of doing this in a planetarium that's tactile. It's over their heads so they can actually feel it. There are many ways to do these things. So astronomy can be used for accessibility, for equity, to give people an opportunity in many more ways than I'm going into here. There are a lot of different things, and if people are interested, they can contact me in that. But there are a whole lot of ideas behind all this. Well, but the real aspect of astronomy that that really makes a difference, that fascinates everyone, is it tells us the nature of our existence. It gives us perspective. When we look up, we're looking out there in this picture into the Milky Way galaxy. That's not some other place. That's our neighborhood here. We're traveling through space together. Like Carl Sagan said, the Earth is a very small stage in a vast cosmic arena. And a big part of what I'm doing too has to do with astronomy as the overview effect for the rest of us who won't go into space. The overview effect being what astronauts see when they look back at Earth and see it as a planet orbiting a star on the edge of a huge galaxy. Well, you know, this person in this photo is seeing that as well. It takes a little more knowledge. It doesn't hit you right in the face. But we're on that little speck traveling around, and it looks like there's a bright planet there. It looks like probably Mars. And it gives us this perspective too, that we're part of something much bigger. Sometimes people say, well, it's humbling, it makes me feel small. But my experience is that it makes people feel more important. They feel more connected, just as the international organizations I've been a part of. When people join, they feel connected to other people, a part of something bigger than their own little neighborhood. And that makes a big difference. So this is, I think, why astronomy is really so fascinating to so many people. This is actually the summit of Mauna Kea in Hawaii. And yes, at 13,000 feet, there's plenty of snow and ice in Hawaii. Looking out at the Milky Way galaxy, this is a panorama. This is what you would see if you turned your head at that moment looking there. This is what our galaxy looks like. We're looking towards the center, and somewhere buried in the center of that is the massive black hole we now have a picture of. So when it comes to a final comment in terms of what it's like to do public outreach in astronomy, I have one more thing. Okay, no comment there. And that is the last slide of mine.
Okay, well, thank you so much. Appreciate that, Mike. Yeah, the bit about the folk wanting me to warn the Apollo astronauts to, you know, not try to stand on the moon because it was just some kind of special cloud. I had to then, well, I then said, well, no, it's not. It's really, like it's this big rock. And of course they laughed because, you know, if it was a big rock, it would just fall to Earth. And,
and you know,
if I had a ball of twine, I could have tied a rock to it and swung it around my head, perhaps, and gotten somewhere. But as it was, they just knew I was nuts.
Yeah, sometimes you just have to go with the flow and be the nutty guy from another place. And you know, these things, none of these things, of course, we all have a problem with the people look at the evidence and decide that it's either fake or they interpret it differently because they've got some agenda. But the people who simply don't understand those, like what you're talking about, I can't blame them.
Yeah, true.
And it makes sense, just like a flat Earth makes sense.
Yeah.
But we get an opportunity to present information and that look of awe of the little boy from Romania looking through that solar telescope. That's what we get. That's why there are tens of thousands of people around the world who do this and share their passion and their understanding and their perspective of our existence with other people. It's awesome.
Yeah. I was very privileged that when I was in Africa, I lived over 2,000 meters high and there was absolutely no light pollution, whatever. It was glorious.
Fantastic.
Oh, well, now a word from our sponsor. We have Taco Truck Lager. And we're ready for questions. Okay, Jay Diamond has a question. The latest photo of the supermassive black hole at the center of our galaxy is terrible. I've taken better drunk pictures on my cell phone. Why can't we do better?
Okay, so this black hole is supermassive. It's really, really, really big, but it's really far away. I think somebody said, somebody gave an analogy, because we have to do these analogies. So it's something like looking 3 or 4 or 5,000 miles away and seeing a donut, So that's one of the things. The other is these pictures are taken in radio. You can't see in visual light the center of the galaxy. There's a bunch of dust and stars and all this stuff that's in the way, so you can't get there. Certain wavelengths of radio will penetrate, and we can pick up those radio waves from the supermassive black hole. But radio waves do not, using that, you don't get nearly the resolution. You can't get as fine detail because it's a longer wavelength. I won't go into that really, but you can't get as clear a picture with radio. It's like having bigger pixels. And so if Jay was able to take a drunken photo using radio with his cell phone, it would not look as good. But the main thing is it's just really far away and it's hard to see. And the fact that we can get anything from it at all is pretty amazing.
Okay, Eugenie Scott has a question. So people in countries where they don't trust the government embrace conspiracies. As skepticism of our government increases, would you predict even more conspiracies? Is there a general relationship?
Well, I certainly see more conspiracies in the US now than before. No question about it. Some of the old things that people dropped a long time ago are coming back up again. So this is my theory about why other people say, well, I think the government's doing this or this and this. They don't trust anybody, and I don't blame them for it. So that's my idea. I think that this is a more natural for them. But yeah, I definitely see more of that here. Don't you, Eugenie? I mean, goodness. It certainly seems like we have far more of that now here than we have before.
Ray Howard has a question. I'd like to hear Mike's view of the claim that comets are electric and made of plasma.
I haven't heard that one. It looked like it, that's not unreasonable. But we have landed on comets. We have landed on the nucleus. The thing about comets is that they have a solid nucleus, but they are made out of dust and solids that evaporate. And so when they come in close to the sun, they get warmed up. They get hit by the solar wind, which is particles coming off of the sun. And so this stuff starts to spout out. I mean, you can actually see geysers on the nucleus of a comet where things are shooting out. So what we get are two different tails. Dust, which is pretty simple. And gas, it is not a plasma. It's not that hot. It's not that sparse. It's true. Somebody once said many years ago, the comet's tail, Earth probably went through the tail of Halley's comet in 1908. No effect, because there's so little there. It's just really, really, really long. And so you can see it. Somebody once said that a comet's tail is the closest thing something can be to nothing and still be something. So it's there isn't much there. But no, it's not electric. It's not plasma. We know comets really well. We visited several now.
Brianna Ibarra, which conspiracies do you feel strongly about?
Ooh, well, you mean positively or negatively? There aren't too many that I like, so I'm going to assume that this is asking which ones do I really bother me the most. Oh, so many good ones to choose from, or bad ones, however you look at it. I mean, one of the things about the business with the moon hoax, I've known some of the people that were there. I actually met Buzz Aldrin in the 70s, and he was going that night to see the movie Capricorn 1, which was about a faked landing on Mars. And he was pretty insulted by it. I think, you kind of take it personally when it really affects a person like that. Otherwise, I think, conspiracies. Well, unfortunately, the whole thing about NASA, people do not understand what NASA does. There were commentators when the space shuttle program ended that said, well, the US doesn't have a space program anymore. Well, the space program, it hardly made a dent in the space program of the US. We have all these satellites doing work in space, looking back at Earth for weather, prediction of hurricanes, geology, famine, so many different things. And then we have these robots going out in our name all over the solar system and giant telescopes. So I think I'm really bothered by the fact that people don't know what NASA does.
Yeah. When I was teaching middle school, about the same time as the Apollo astronauts were on the moon, very few of my students thought that they were really there on the moon.
Really?
Sadly.
And that was where?
I was in Los Angeles in middle school.
That's bizarre. But I heard about it being faked long after that, but
no, during the time.
but during it, yeah.
Maxwell Peterson, what's the most interesting cosmological myth you've encountered in your travels? Ooh, that's interesting.
Yeah, I have trouble picking favorites. This is a really interesting area. I'm going to answer in a more general way because this is a really important area, I think, and it's one of the things I wanted to do for a long time. I know people who deal with the cosmologies of different cultures all around the world. We have, they're well known in Australia, but also in Africa, different areas in Africa. And, people come up with these myths in order to explain things around them. And they may or may not actually believe it, because not everybody believes that there are giant animals of some sort that are up there doing things like that. What I find interesting is that there are these myths in every culture.
Yeah.
And some of them, if the people have not learned more, they still hold on to them. But I think they're important. And I really think there are people I know who are working on these things, and I really think that needs to be supported because this is an important part of our heritage. We have looked up to the sky as long as there are histories being written. And those myths, if you look at the Greek myths about what's going up in the sky, or the Roman ones. It's not really about the sky. It's about us. They are projecting us into the sky and the gods. As far as what I find most interesting in problems, I find them all really interesting, Maxwell. So it catches me a little off guard. It's not my main thing, but there are just so many, and I can't really think of many right now. But they're all valuable as far as I'm concerned.
Eugenie has another question. Introductory astronomy years ago was often considered the easy science distribution course for non-science majors. Are university astronomers innovating to reach, inspire, challenge students these days?
Oh, I don't know where you went to school, Eugenie, but introductory astronomy usually turns out to be something that people think will be easy because it's about looking up at the stars, and it's not. Astronomy is physics and math, and for non-physics and other science majors, you make it as easy as you can. But it's not so simple. It really is, kind of still doing physics. So university classes these days are definitely more challenging than what you've described there. And again, to me, I think there should be more astronomy taught. I and many others think astronomy should be a part of high schools, middle schools, elementary schools even, because it is a way to grab the student's attention that is more likely to do it than many of the other sciences. It's just more universal. So yes, they're more challenging. I don't know if they're doing any better job or making a real attempt to reach the non-science majors, but I do know that a lot of non-science majors go into astronomy because they're fascinated by Hubble images, and they find out that they're actually doing science, and it's not always what you think or as easy as I think.
Okay, we have any more questions, or are we wrapping up here? Looks like we're wrapping up. Yeah, there was so many things that went on in teaching middle school, having to do with all different kinds of science. And the best part of teaching it is that you're opening up eyes, and that's what I loved.
Mm-hmm.
Okay, again, Mike, our sincere thanks for your time and for your presentation.
It's my pleasure, really.
Well, next month's SkepTalk will be how to talk to a science denier. Conversations with flat earthers, climate deniers, and others who defy reason. It will be presented by Lee McIntyre of Boston University, and that's a month from now. This month, Wednesday the 25th, we'll have this month's Skeptics virtually in the pub. Information on that is forthcoming. Also, tickets are on sale now for July's Skeptical Conference, Convention, excuse me, or conference. Yeah, it's a conference. With Steve Novella, Bill Nye the Science Guy, a host of others. However, ticket prices will go up on the 1st of June. So, get onto that. So, folk, until we meet again, stay well, stay inquisitive, and keep expanding your circle of empathy. Good night.